Good morning all. Last day we have studied about operating system. And operating system acts as an interface between hardware and application software. So it will manage all the hardware devices and all the software resources assigned to the system. And today we are going to learn about kernel. And kernel is the important part of an operating system. Without the kernel, operating system cannot work. These are the topics which we will cover in this session. Initially, I will give an introduction to kernel. Then I will move on to various functions of kernel. And it included memory management, device management, resource management, etc. Then I will move on to classifications of kernel. In the last class, we have understood the concept of operating system. Operating system is a software which is act as an intermediary between application software and hardware devices. So it facilitates the communication between application software and hardware devices. So whenever the application software need to communicate with the hardware devices, it can contact the operating system, and this operating system will facilitate the interaction between application software and hardware devices. Here in the core part of the operating system, there will be one program, and this program is called kernel. So it is said that kernel is a computer program at the core of the operating system with a complete control over everything in the system. So this kernel has complete control over everything in the system. It means that it is managing both hardware devices and application softwares. So it says that the kernel is the integral part of every operating system. So the operating system cannot work without a kernel, and it will facilitate the interaction between hardware and software component. So it is just as act as an intermediary between hardware and software component, and it also the first program which is loaded on the startup. So kernel is loading at the startup or boot up of the software, and it handle both memory and peripheral devices. Since the kernel has complete control over everything in the system, it also has control over memory and peripheral devices. So it can handle both memory and peripheral devices. These are the services and functions which is provided by the kernel, and it is more similar to the functions and services of an operating system, because kernel is main part of the operating system. So the services and functions provided by the operating system should be almost similar to services and function provided by the kernel. Here we can say that these are the services which is provided by the kernel. It include device management, task management, synchronization and communication, memory management, timer management, and interrupt handling. Here these all services also will be provided by the operating system. So in an exam, if they ask the services and function provided by the operating system or kernel, but the answer should be both answers should be same. Now we are moving on to various functions of kernel in detail. The first function of kernel is inter-process communication. In a multiprocessing system or multitasking system, multiple tasks or multiple processes are running simultaneously. Such a time, one process may be need to make a communication with other processes. So kernel is providing a method for achieving this communication, and this method is called as inter-process communication, and it is defined as a mechanism provided by the operating system which allows process to communicate with each other. And there are various approaches for inter-process communication, say semaphore, shared memory, message queue, pipe, etc. So the kernel is providing this inter-process communication method. So various processes can be communicated with each other. The next function of the kernel is CPU scheduling. In a multitasking operating system, multiple processes can run in tandem. It means that in a single CPU, only one process can run at a time. So all other processes need to wait in a queue. So when the CPU is available, the kernel will allocate or assign any of the waiting process to the CPU. And this is called CPU scheduling. And it says that it is the process of determining which process will on CPU while another process is on hold. So here the kernel will use a scheduling algorithm to determine which process needs the CPU most, or which process has higher priority, and it will allocate higher priority process to the CPU. So it says that kernel uses a CPU scheduling algorithm to determine which process is running next and how much time it will be given. The algorithm set priority among the processes. The next kernel function is the resource management. In a computer system or an embedded system, it is associated with multiple hardware and software resources. The hardware resources can be CPU, memory, I/O devices, etc. And there will be a lot of software resources also. And kernel manage all these hardware and software resources. So it says that the kernel's primary function is to manage computer resources and allow other programs to run and use those resources. So these resources includes CPU, memory and I/O devices. The next function of the kernel is the process management. A program in execution is called a process. So in a multiprocessing system or multitasking system, we can find a lot of processes executing in tandem. So the kernel should allocate resources to each processor, and it also allow various processes to communicate with each other, and it also should provide synchronization among these processes. So it says that the operating system must allocate resources to process, enable process to share and exchange information, protect the resources of each process from other process, and enable synchronization among these processes. So all these activities are achieved using kernel. The kernel also should provide memory management services. In a computer system, there can be two types of memory, primary memory and secondary memory. Primary memory is nothing but the RAM of the computer system, and where the execution of the process is taken place. And the secondary memory is nothing but the internal storage. It can be a hard disk or it can be a memory card. Normally a program resides in the secondary memory. When the operating system or kernel start executing the program, it will bring to the primary memory. So the kernel should allow two operations in memory management service. First one is the memory allocation. Here when a process is started, all the information related to the process should bring to the primary memory from the secondary memory, and it also support swapping. Here when the process is no longer executing or process is in hold, all the data relating to the process should bring back to the secondary memory, and these services are achieved using kernel memory management service. The next kernel function is device management. We know that in a computer or an embedded system, there will be multiple peripheral devices attached to the system. And these peripheral devices can be a keyboard or mouse or a monitor, which will be in the case of a computer. And in the case of an embedded system, these peripheral devices can be various sensors and actuators. And for the proper operation of the system should have a consistent communication with the peripheral devices, or the operating system should have a consistent communication with the peripheral devices. So in order to maintain a consistent communication with the peripheral devices, the operating system or kernel uses device drivers. So the program situated in the kernel, which is called device drivers, is used for communication between various peripheral devices. So it says that to perform a useful function, process need to access the peripheral devices connected to the computer, which are controlled by kernel through device drivers. Device driver is a computer program that operates or control a particular type of devices that is attached to a computer. And device driver provides a software interface to hardware devices, enabling operating systems and other programs to access hardware functions without needing to know precise details about the hardware being used. And device driver is a hardware dependent and OS specific program. So each devices working in the system should have separate device drivers, because only one device driver can handle only one type of devices. Next kernel function is interrupt handling. We know that interrupt is a signal which is sent by some hardware devices indicating some events, and all the interrupt should be handled properly. And this interrupt handling should be done in kernel mode or privileged mode. So it says that when an exception or interrupt occurs, execution transition from user mode to kernel mode where exception or interrupt is handled. Here you can see the timing diagram of interrupt handling procedure. So here there are two modes. One is user mode execution and another one is kernel mode execution. So this blue region shows kernel mode and this green region shows user mode. And almost all the programs are executing in user mode. So here you can see a program is executing in user mode. During the execution of the program, a external event has happened or the CPU received an interrupt. So when the CPU received an interrupt, the CPU need to switches to corresponding interrupt handler. So CPU will CPU will save the context of the executing process in the memory. Then it will switches from user mode to kernel mode. And in the kernel mode, the CPU execute corresponding interrupt handler. And after completion of this interrupt handler, then CPU switches back to user mode. And there it will restore all the context information which is stored earlier. Then it will continue execution of the process. Memory of an embedded system or a computer system is classified into two: kernel space and a user space. And this kernel space is used for executing all the privileged instruction, and the user space is used for executing all the unprivileged instructions. So it says that user space is a memory segment where the user process run. Since user process is an unprivileged set of process, it is executing in user space. And kernel space is a location where kernel programs are stored and executed. And this memory location cannot be accessible by any other user programs. So the kernel space is not accessible by user space application, but the kernel space application is capable of accessing the user space programs or user space memory, because kernel space applications are privileged application, so they are able to access the user space memory also. Next kernel related term is the system call, because we know that all the privileged application or all the kernel application is running in supervisor mode or in kernel space, and user programs cannot access the kernel space. So in order to obtain various services from the kernel, the user application uses a system call, and using this system call, the user application can access various services given by the kernel. So it says that kernel system call is a method by which application or process requests a service from the kernel. And system calls are the only entry point into the kernel system. So the application can access the kernel services only through system call. So there is no other method for accessing the kernel space programs, or no other way to access the kernel services other than the system call. And there is various method for invoking a system call. This include software simulated interrupt, using a call gate, using special system call instruction, or using a memory based queue. So here, using any of these set of techniques, the user application can access the kernel services using system call. The kernels are classified into mainly 4 types: monolithic kernel, microkernel, nanokernel or picokernel, and a hybrid kernel. The most popular types of kernels are monolithic kernel and hybrid kernel. In a monolithic kernel, there is a single program that contains all the operating system core functions and device drivers. And this type of kernel is used in Linux and Android operating system. The next one is microkernel. And in microkernel, near minimum amount of software that can provide the mechanism needed to implement an operating system core function. And this type of microkernel architecture is used for embedded application. And next one is nanokernel or picokernel. And this is almost similar to microkernel, but the code which is executing in the privileged mode is less than microkernel, or it is very small. And last one is the hybrid kernel. This hybrid kernel combines the advantages of both the monolithic kernel and microkernel. So it says that a hybrid kernel is an operating system kernel architecture that attempts to combine aspect and benefit of a microkernel and monolithic kernel architectures used in computer operating system. And it is mainly used in Windows operating system. Here we are going through classification of kernel. So I am going to discuss various type of kernel in detail. The first one is monolithic kernel, and it is a single program that contains all the operating system core functions and device drivers. So here in this monolithic kernel image, you can see there will be device driver, file system management services, and memory management services. All these services or all these privileged services are included in the monolithic kernel. We can look various features of monolithic kernel. It has rich and powerful hardware access capability, and it is easier to implement than all other types of kernel. But the problem with the monolithic kernel is that a bug in the device driver might crash the entire system. So the device driver should be made bug free or error free, and for a large kernel it will become very difficult to maintain. And these are some examples of monolithic kernel: Unix, DOS operating system, Linux kernel. And in Linux kernel we can see 28 million lines of code, and it is used in Android, Ubuntu, Fedora and CentOS operating system, etc. Now we are moving on to microkernel. The microkernel contains near minimum amount of software that can provide the mechanism needed to implement an operating system core function. Here in this diagram you can see there is a microkernel, and in this microkernel block, this block contains a near minimum amount of software needed to implement an operating system, and all other part of the operating system is bring outside the microkernel, such as device drivers, memory management and file system services. And these three services are running in user mode, and it is made bring outside the kernel module. Now we are going through various features of microkernel. In a microkernel architecture, if a service crashes, it never affects the working of a microkernel, because in a microkernel operating system, all the services are implemented outside the microkernel. So if one services get crashed, it won't affect the working of the microkernel. And this microkernel interface help you to enforce a more modular system structure. Here, the most important part of the operating system is implemented using the microkernel, and all other software or all other services are implemented outside the microkernel. So we will get a more modular system structure, and it only need fewer lines of code than monolithic kernel. And microkernels are modular. The different module can be replaced, reloaded, and modified without even touching the kernel. In the case of a kernel, if you want to modify a device driver, we have to reload the kernel completely. But in the case of the microkernel, we can modify kernel modules without touching the microkernel. And the performance of the microkernel kernel system can be indifferent, because many of the software placed outside the kernel, the performance of the kernel is lower than the monolithic kernel. And one example of the microkernel design are Minix 3 operating system. Now we are moving on to hybrid kernel. This hybrid kernel combines benefit of both monolithic kernel and microkernel. The example of hybrid kernel are Windows NT kernel and XNU kernel. The Windows NT kernel is used for implementing Windows XP, Windows 7 and Windows 10 operating system. The XNU kernel is used for implementing Mac OS and iOS operating system. Here you can see the diagram of a hybrid kernel. And in this diagram, you can see there is one microkernel and some kernel mode drivers also present in this microkernel. And along with the kernel mode driver, some executive services also there. And here in this executive services, less important services are placed in this executive services. And in the microkernel, the most important services are placed. And some kernel mode driver also present in this microkernel. So the combined in this block is can be represented as a hybrid kernel. So we can compare monolithic kernel, microkernel and hybrid kernel using this diagram. Here in the first diagram, it is representing monolithic kernel. Here in monolithic kernel, almost all the operating system services are placed, such as system call, inter-process communication and file system services, scheduler, virtual memory, device drivers and dispatcher, etc. All these services are running inside the monolithic kernel. And in microkernel, only very basic services necessary for implementing the operating system is placed, like basic inter-process communication, virtual memory concept and scheduling. All other types of services such as file system service, device driver service, Unix server and application inter-process communication are placed outside the kernel. But in the hybrid kernel, the basic along with the basic services, some other services also placed in the kernel mode, such as basic inter-process communication, virtual memory, scheduling, device driver and application specific IPC also placed in kernel mode, within the kernel. Other services are placed outside kernel, like Unix server and file server. In this session, we have studied about kernel. Kernel is the important part of the operating system. Without the kernel, the operating system cannot work. Then we have seen various functions of a kernel, and these functions include device management, resource management, memory management, interprocess communication, scheduling, etc. Then we have seen various classification of kernel, such as monolithic kernel, microkernel, and a hybrid kernel. Then we have seen various advantages and disadvantages of each types of kernel. So I am winding up this session. Thank you for listening. See you tomorrow.